Hello and welcome to a talk on Sistema Silvana, a recent discovery in our explorations of the caves and lava tubes of the Galapagos Islands in Ecuador. The Galapagos Islands are located about 1,000 kilometers off the coast of Ecuador in mainland South America, and the location that we'll be discussing today are some caves that were found on the island of Santa Cruz, which is approximately under the word of islands. The Galapagos Islands are formed over a hot spot. If you're familiar with the Hawaiian Islands, it's much the same origin story there. So we have a mantle plume that's rising up from the core, and over time the plates drift from east to west, and it's leaving what's called a volcanic trail where the basalts manifest themselves on the surface of the ocean. So you can see on the diagram on the lower right that the islands are also at a plate boundary between the Cocos Plate and the Nazca Plate. These are the plates that are involved in subduction under South America and responsible for the large earthquakes that you hear about. If we zoom in and look a little bit closer at the island of Santa Cruz, you can see the surface geology here, the flows that are all radiating from the top ridge line of the island that's migrated over time. This is characterized by several different pit craters and evacuated magma chambers that we see as leftovers of past volcanic activity. And the cave system that we're talking about today will be found here on the north part of the island. These flows will be moving primarily from the top of the island towards the north. 2020 marked our 10-year anniversary of starting the exploration and documentation of the caves in the Galapagos. As you can see on the right-hand side, we've mapped several caves on the islands. Again, today we're going to be talking about Sistema Silvana, which is just north of center on the slide. It looks like a little Y, and as I mentioned before, it'll be flowing to the north. To give you a little bit of an idea of what the terrain looks like on Santa Cruz, here's a shot from a massive collapsed magma chamber called Cerro Mesa. So we're looking to the west in this photo, and you can see the top line of the island there and above the center of the photo. And then again, the systems that we're going to be looking at today are off to the right. So they'll be flowing downslope at approximately 4 degrees. And making their way towards the ocean. We began our exploration of this area of the island in August of 2019. We had a team made up primarily of Americans and Ecuadorians, but we also had 2 Italians that joined us from the group La Venta. The first cave that we entered in 2019 was a small tube shown to us by goat hunters that we wound up calling Cueva Calor, since it demonstrated a much hotter, what we believed at the time was a much hotter temperature profile. Calor, like many of the lava tube segments on Galapagos, is just a different entry point of the lava as it makes its way down the surface. Typically, these entrances are either breached at the roof or have very steep down slopes where lava began flowing again underneath the current ceiling or surface. So here we're looking down into Cueva Calor at the beginning of the survey, and you can get an idea of what that layout looks like. Calor had a much steeper profile than most of the caves on the north side of the island. This probably speaks to it flowing over existing or pre-existing rather flows and different buildups of lava over time. Here we see Rick Haley and Scott Lynn looking back upflow. You can see even from where I'm set up with a camera in this photo that we see a braided section of the tube with Rick looking up to the right and then Scott looking back towards the entrance. As I mentioned, there was a small braided section in this cave, and typically in Galapagos, the braided sections pancake out or get really low. They may only be 1 meter or 2 high as the lava finds its way around an obstruction and then rejoins to the main conduit. In this photo, Rick and Scott are in the main conduit of Calor Cave, and you can see some of the breakdown area that forms a big chamber in the cave. And here we are exiting the cave after a day of survey. You can see a nice solid wall on the right and breakdown in basalt on the floor. But we do have some bottlenecks sometimes with the climbs since things can be very unstable. It's quite hot in the Galapagos since we're on the equator and we're at sea level, so staying hydrated is a very important part. Most people carry between 3 and 4 liters of water to get them through a single day of caving, and primarily you're drinking as much water on the surface as you are whenever you're in the caves. You also see one of our Ecuadorian colleagues, Teo, in this photo, and he's on his phone. One of the things that's really interesting about caving in Galapagos is that you can be out in the jungle quite far, several kilometers, and still have cell phone signal since it's an island and you're at the high point on the island. There isn't really heavy forest cover in terms of tens of meters of tall trees and things. It's all lower scrub. A few invasive species trees can get up to 10 or 20 meters tall, but they're few and far between as a rule. So it's quite common to hear somebody's phone going off as they exit the cave. This next series of photos will be in the main system of Silvana, or cave beneath the forest is the translation. And as you'll note that this is a much larger conduit, it seems to be the main conduit for this system. Calor and several other caves that I'll speak of are more satellite caves. We are slowly connecting some of these caves to the main conduit. So we're hopeful that exploration will continue to yield interesting discoveries as we continue to document this very lengthy lava tube system. Here, Bob Osborne is sketching with the help of Elizabeth Winkler. Bob is one of our main sketchers on the expeditions and does a fantastic job for us. Surveying can be quite a challenge in these lava tubes. If you've ever surveyed around lava, or maybe have heard stories or reports of surveying in places like Hawaii, you'll know that it's very difficult to get angular agreement on your azimuth. The process that we work, it's by no means perfect, and it's certainly not the only way to accomplish reliable compass readings, but the process that we use is redundant disto X readings, and then we verify every single azimuth with the Sunto. One of the things that we found early on in our work in Galapagos is that it was not productive use of time to try to get a back shot and a foreshot to agree. You may only get a dozen survey shots a day done with that methodology. What we have found is that we can generally get agreement after some work between a disto X compass reading and then verifying that with a handheld Sunto. That also helps us to verify whether or not our disto X is drifting out of calibration or has lost its calibration, and we can accommodate that into our survey. And we also have backup instruments that we carry, generally Sunto dual units with clinometer and compass. This is a characteristic collapse of one of the entrances to Silvana. Here, Rick Haley is starting a survey. Since we're in the daylight here, we were having difficulty getting a disto reading. So it is still the prudent survey crew that carries a tape with them for just such cases. Here we see a nice ledged out area and trough channel cut in the lava where we have benches on both sides, and the lava flow remnant is there in the floor. Things do choke down from time to time. We get these small channels and small crawlways that go over the top of them. Here Scott's looking ahead to the next survey station. One of the really interesting thing about these lava tubes is, most lava tubes don't go very deeply underneath the surface, but in the case of Silvana, you get these pinhole skylights throughout the entire length of the system. Here, Rick Haley's standing underneath one of these small skylights, so the light that you see on his orange shirt is actually sunlight coming through a hole that's maybe about 10 centimeters in diameter. We do see secondary mineral deposits in the lava tubes of Galapagos. Here it's a glove for scale next to some secondary deposits that are directional in nature. meaning that they point in the direction of the airflow. These could be calcite, these could be something else. They haven't really been looked at very closely. Here's a much deeper, more definitive trench in the floor. You can see with the Teo standing there for scale, it's about a meter, meter and a half deep, with well-formed benches on both sides, and it's undercut by about the same amount back to the main, if you can imagine the main walls of this conduit, that this flow may have been a part of the original lava tube formation, or it may have been a secondary flow that came at a later time. As I mentioned, some of these areas get quite small. This is a belly crawl that Teo pushed through. This is one of those braided sections that I mentioned earlier, where this gets very small with a lot of wind whipping through it for about 3 meters, and then it opens back up into walking passage again. This is one of the side passages that we surveyed. You can see it from both directions in these two photos, with a nice horseshoe-shaped rim around the ledges. And the flow terminates underneath that horseshoe shape as well, where the tube comes back out on the surface. The main tube is quite large though. Here you can see Rick standing by one of the skylights. So travel times, while it's very hot in this cave, travel is generally pretty easy. Another photo of Rick showing the dimensions and characteristics of the passage. You can also see in this photo some of the nice oranges and blacks and whites that characterize the passage walls. There are some lava sickles and other drip formations in Silvana. Here Scott's examining some that are formed along the wall. These are quite hard. You definitely don't want to bump into them. They'll tear clothing or skin if it's in the way. Occasionally large areas of the benches or the walls break off in large sections, and here you can see one of those that has the lava sickles on it. Again, these are quite hard and not something that you would want to fall against. Just another photo to show characteristics of the passage. This is looking upflow into the next skylight. Silvana tube is very similar to a nearby tube called La Ligada, which has been discussed at previous exploration sessions. Here's Rick going down into the next tube segment, but this tube segment is nearly 10 meters tall, and in places more are wider than that. You can see though overall it's maybe 5 to 7 meters wide in the main trench, characterized by alternating soil on the floor, especially close to the skylights, some breakdown, some pahoehoe. Rarely do we see very long stretches of pahoehoe in these caves. It's more like and just breakdown chunks of lava. Some of the skylights are quite photogenic. This one's a bit overexposed. I was taking pictures with my traveling camera, not really a photo trip, but doing the best that we could with the equipment that we had. Another look up into one of the skylights. One of the interesting characteristics of Silvana is that it makes these big sweeping S-bends. Here we're in one of those bends looking down into the next tube segment. You can see ferns and other vegetation growing on the floor and the walls here, along with some lichens and so forth that you might expect in daylight. But these big S-turns do cut off the daylight rather rapidly. And since it is so abrupt, it's also good habitat for barn owls to live, and we see barn owls quite frequently in the caves. Here Scott and Rick are trying to get a disto reading in daylight. I think we had forgotten the survey tape on this day, and it took us probably a good 10 or 15 minutes to get a usable disto shot here. Here Scott's climbing up to take a look at where we're going to set our next survey station. Scott was my point man for almost the entire expedition and did a great job for us. And we've got a pretty small group of cavers that have worked for the past 10 years consistently. We do have other folks that come and join us from time to time, but the small core is responsible for the the bulk of the surveying that's been done, certainly in the last several years on the island. At the end of our expedition in the August of 2019, this was our end of survey. We had leads that were going in at least 4 different directions, so we knew we were entering a next level of complication and braided area of the tube system. Here Elizabeth is on the left looking down the main conduit, and Rick Toomey is up on the right looking down a braided segment, and there are 2 more braided segments to his right. Just a couple more photos from that August 29 trip as we left the cave here. I wanted to show some of the areas where the tube splits into 2 levels, so you have a false floor, but yet these passages are distinct and they may or may not completely mirror each other top to bottom. So we do in most cases need to run a survey line down both of these. Here's another example of some of the secondary deposition that we see in the caves. This is a white powdery, almost moon milk kind of substance. It may be moon milk, it may be something else, but hasn't really been studied extensively. Another nice shot of the main conduit here where Scott and Rick and Elizabeth are lighting with just their headlamps. Sometimes these split tubes or split level tubes happen at the skylights, which again makes excellent habitat for the barn owls to set up high and watch what's going on in the cave with whatever level of light that they want, and then they can just swoop down on their prey. Here you can see Rick and Scott lighting up the main conduit with the benches on the sides and the on the floor. This is an attempt with just my Sten light and my camera handheld, unfortunately, to try to photograph what were some really nice lion's tails that formed on one of those false floors as it opened back up into the main conduit. Here Scott's looking up at one of the skylights. We do try to take GPS locations at each skylight. It helps with the correction, the compass corrections, and we can verify our travel through under the ground that way. But unfortunately, it's not always easy to get up or even possible to get up and out of the cave to get a good GPS location. So we returned in March 2020, right before all of the lockdown for the pandemic happened, to continue to push leads in Silvana. And here we're traveling back down to our Indus survey through the main conduit of the system. One of the nice things in Silvana is occasionally you do get glimpses into how different features formed. Here you can see a real nice cross-section of the benches and the way that they get built up by the various layers of lava cooling one on top of the other. Occasionally the tube segments are very short, and so here we're in daylight looking through a tube segment into daylight again in the next skylight area. These areas are used pretty extensively by goats. Goats are invasive on the islands. In fact, there's a very targeted eradication program to try to hunt down and kill all the goats. But out in these remote areas of the islands, we do still see evidence of goats. And once in a while, you can, if you're quiet and come into a skylight, you might hear some goats or even possibly catch a glimpse of one up on the surface. We do have one tight spot on the way on the travel through the cave down to the end of survey now. So this is just a big lava constriction. Here we're passing packs up through this little chimney, but there's a way to climb up and around or to just chimney up this crack. Most people climb up and around going into the cave, and then using gravity as an aid, they go back down through the chimney on the way out of the cave. As I said earlier, traveling through the cave is quite easy. Here you can see a mostly flat floor, for probably over 100 meters in a straight line distance. Here Rick Toomey is standing under yet another skylight, and you can see the smaller blocks of lava on the floor and the various benches along the wall, which are an indication of multiple flows using this same tube over time. Here you can see some of the flow on the floor of the cave. This is an area that we were surveying in one of those braided tubes beyond the end of survey from 2019. So this is an area that we discovered just a couple months ago. So where are things at right now with Sistema Silvana? This is the survey that we were able to complete in August of 2019. You can see the main conduit on the right, the Calor system, the Levia system, and a couple other small satellite caves. You can see segments that are nearing connection. Our parking area is down at the quarry on the lower left, and so we have to cut trail through the jungle, which is about half a kilometer right now. And travel time to the end of the cave during August of 2019 was about 3 or 4 kilometers round trip, and dropping down 100 meters downslope and then recovering all that whenever you have to hike back out. So you heard me say earlier that we drink a lot of water, and this is the reason why, is that there's just long distances to be covered whenever you're exploring these caves. In this map, you can see La Ligada, the cave to the north, and you can see Sistema Silvana at the lower left or on the south end of this photo. These two caves are obviously of similar flow, if not the same flow, so time will tell if we're able to connect these two, but that would make a 10 kilometer plus long system if we're able to do that. As I mentioned, we returned to the cave with the original team, plus Jason Richards and Chrissy Richards that joined us, and Hein Angermeyer from Ecuador also joined us. And we were able to add more survey to the cave. So in this map, we're looking at the blue survey is from August 2019, and the yellow survey are the braided sections and various connections that we were able to make in March of 2020. So the current length of the system is about 4.2 kilometers, and the depth is 195 meters. So one of the things that we're trying to do is understand the flow boundaries for this system and what the potential might be for the cave. You can see the ocean up at the north end of this photo. Clearly the cave is flowing downhill and towards the ocean. The white lines attempt to delineate the flow boundaries as seen on the aerial images from Bing Maps, Google Maps. This is certainly not an exact science because a lot of this is covered heavily in vegetation, but it does start to give us an idea of what distance we've covered in this flow so far and what potential remains for this particular lava tube system. And so you can see from this photo, we've barely scratched the surface of this flow. Now that's far from a guarantee, of course, of being able to find continuous cave that goes all the way to the ocean or most of the way to the ocean. But this does start to give us some idea of what we might be able to look at if we want to go out and do more surface work and find a different entrance to the system where we would want to focus those resources. So at the conclusion of March 2020, we were able to add the additional survey to Sistema Silvana. We've mapped a couple more shorter caves, one Cueva Cando about 1 kilometer long. But you can start to see our evolving work on the caves of Santa Cruz. So there's about 22 kilometers of cave survey on this map, including the longest known lava tubes in South America. To the east, you have Cueva Cascajo. To the south, you have the Bella Vista system. And then, as I've been talking about today, to the north, you have Silvanas and you have La Ligada. So if we look at the data in August 2019, we spent 8 days in the field. We added 7 new caves to the database. We set about 300 station at an average shot length of about 11 meters. The small team was able to survey a little over 3 kilometers, and we pushed the totals for Santa Cruz Island to about 1,500 in-cave stations and a little over 19 kilometers of survey. If we jump ahead to the work we just completed in March 2020, we spent 8 more days in the field. We added 9 new caves to the database, and we set about 435 survey stations. Our mean shot length was a little bit shorter at 9.5 meters, but we surveyed just over 4 kilometers, and we pushed the total for Santa Cruz Island to over 23 kilometers and about 1,900 survey stations. So if we look at Sistema Silvana in particular in March 2020, it's a little over 4.1 kilometer of underground survey. I know earlier I said 4.2 kilometers, but that includes some of the surface ties between segments of the system that are not underground. It's at 196 meters deep right now, and the total system, including the satellite caves, is about 4.9 kilometers. The one thing that we were able to accomplish during this expedition is that Sistema Silvana is now the longest known lava tube in South America. So with that, I'd like to thank the Galapagos National Park for their cooperation with our research permits, the NSS International Exploration Grants, and the support that they've given us over the years, SB, the Polytechnical University, where our colleagues work in Quito in Ecuador, and importantly, I'd also like to thank specifically Hein Angermeyer. Hein is a caver now that we've indoctrinated, but he also is a guide with the Galapagos National Park, and he grew up in the Galapagos, so he's been an invaluable asset to our team in terms of finding new caves and getting access to areas that maybe would be more difficult or impossible for us to access otherwise. So with that, I'd like to thank you for listening to our talk on the updates for Galapagos and Sistema Silvana. Thank you.